All right, part 5 of this build. I've got it built into LTSPICE so we can simulate the circuitry. So that's what we're taking a look at here. All right, here we go with part 5 of this amplifier build. So if you remember, the last section we were doing the second draft of the schematic, and I have it here on the computer. So if you can, I know it's hard to see here, but what we had was a plate follower going into a cathode follower, into the tone stack, into a volume control, and into the KT66, all right? So where we left off on our list, let's draw the second draft. I did that. Now determine the operating points and values and construct a SPICE model. So that's what I've gone ahead and did here. So this is the first SPICE model of the amplifier. So SPICE is basically a program, like a CAD program for electronics, where you can build circuits and operate them in a simulation. So which is great because you can get all your values, you can play with your values, and all the parameters, and set up how you want this amp to run exactly how you want it before you build the physical version. So this is basically the same thing we had here, just written out. So we have this is a mock AC source, a signal source at 500 milliamps or 500 millivolts, excuse me, which is just about the amount of signal you're going to get out of a guitar amp. And that's going to go into here, into the first section of the 6SN7, which is a plate follower, going into this cathode follower, the second half of the 6SN7, driving this tone control. I don't have a potentiometer, so this program doesn't really have potentiometers in it. You can build one, but for the sake of doing this, what I'm really trying to do is just detail the output section, or the input section, excuse me, the input section, which we also call the preamp section, and trying to get the values for that, right? Because the operating points of my preamp section are going to determine how my tone control works and how my output section works. So this is what I've done thus far, and right now it's looking pretty good. So if you remember in the previous video, in part 4, what I was wanting to determine was how much voltage I could get out of just having this one tube here. Which right now, if I simulate it, we'll look here, and this is the signal I'm getting after this cathode, after this capacitor, coming from the plate follower into the cathode follower, outside the cathode follower into the in this capacitor before it goes to the tone control. I'm getting 13 volts peak to peak, which is pretty decent. It's not bad. If we look at a KT66 data sheet, and we can see the operating points. So this amp, I'm running about probably 420 volts. So here we can see this is the operating point for a triode connected KT66 single tube running on cathode bias, which is what we're going to do. So a triode connection means that the screen grid isn't going to operate on its own, or it's not going to be ultralinear. I'm not going to use an ultralinear transformer. An ultralinear output transformer means that there's usually about a 40 to 45% tap on the output transformer, almost like a center tap, that you would use to power the screen grid, which would also give you some wattage, usually maybe around 3 to 5 watts. But what we're going to do here is operate it in a triode configuration, meaning that we're going to take that screen grid and we're going to attach it to the plate. And this should also help out our wattage. So let's just go over the data sheet here. So again, this is for a triode connected Class A single valve cathode bias KT66. Now we have, and it'll give you two columns of parameters. So the first column is where if you were operating at 270 volts, the column next to it is 440 volts, which is closer. We're going to do about 420 probably. So this is closer to what our operating points are going to be. So the first is your plate voltage. So if you have 440 volts operating at the plate, then you have 400 volts operating at the screen grid, negative 38 at the grid, at your control grid, and had 38 volts of signal going into the control grid with a 600 ohm resistor at your cathode, you'd get 25 watts out of this, which is actually well over what we want to do. All right, so we only want about 10 watts out of this thing. So running it at 13, so running it about half that signal will give us about 12 watts, right? So if we just did really basic math just to give us an estimate. So if we're getting 25 watts out of one KT66 that has a 38 volt voltage swing when we only have 13. So if we just divided that in half, which would give us 19, and did 25 divided by 2, it'd be 12.5. 12.5 is still over 10 watts. So we should be able to power this thing with 10 watts, or with 13 volts coming out of our preamp. It shouldn't bother us too much here. Now again, we can get more specific about that later on, but that's just kind of a brief overview of, just so we feel comfortable with the voltages that we're getting out of our preamp. So going back to the SPICE model, again, that's what we'll have coming out of this cathode, and that's what's going through the tone control stack and into the KT66. Right now, it's pretty close to finished. The next thing I'd have to do would be to detail the values for the tone control. So I haven't done that yet. These are just kind of mock values. I also have a power supply down here that will probably stand. That'll probably be what it is. But other than that, this is pretty close to what I want done. So for my next step, I'll refine this schematic. So I'll do what I just talked about. So I'll pick out the final values. I'll write a final draft. So I'll probably write one by hand and have one on SPICE. Make a final determination of the values, right? And then finalize the output stage. So that's kind of what we just went over, but to go over it again, I'm going to get out on paper what exact values I want for this output stage, because this is also kind of mocked up. So the preamp stage is pretty well certain, but the output stage here, like, I'm not sure what value of the pull down resistor I'm going to use here at the grid, or how much I'm going to cathode, or what value I'm going to use to bias this cathode. But if I look here, I have 33 volts coming out of it with that 500 ohm resistor. So it's looking pretty good. Right now, if I built this, it would work. It'd be a good working amplifier, but we're going to dial it in just a little bit more before we get into making the parts list and then ordering the parts and getting to building it. So yeah, it's looking good. Things are looking good, and again, I mean, that's all we're left with, is defining the values a little bit more, and making a parts list, and heading on to start building the physical product. All right, thanks for watching.